on how to do coin combinations 1 from the CSES problem set. And the problem goes as follows. Consider a money system consisting of n coins. Each coin has a positive integer value. Your task is to calculate the number of distinct ways you can produce a money sum x using the available coins, and they give you an example right here, right? And then they describe the input and the output. And one thing to note here is that they want the answer in modulo 10 to the power of 9 plus 7. If you've never seen this before, they many problems do this when the actual answer gets too big for you to store it, and they just want you to mod it so that the answer stays small, right? So here now I'll be describing how to do the problem itself. So this is obviously a DP problem, dynamic programming problem. It's listed under one. In CSES Problem Set, it's listed under dynamic programming, and well, we're gonna use dynamic programming to solve it. I just said dynamic programming like 50 times just there, but yeah. All right, so let me comment this little part out. Okay, so we want to have we want to describe each states as DPI, meaning that which is gonna store how many ways you can get the sum I using the coins given, right? And then mod of 10 to the power of 9 plus 7. I've stored that value right here as mod, so I'll just do that. And then also right here, I made it so that whenever I type ll, it'll just macro it so that it's ll to long, so I don't have to type long. I could just type ll instead of long, right? Long. All right, so here we go. So now we want to do the transition itself. So how are we gonna get the value DPI? So we want to get this by doing DPI will be the sum of I minus coin 1 plus coin 2, and so on for all the coins, right? So and then we obviously only do a sum if I minus coin whatever is greater than or equal to 0, because because you don't want it to be negative, right? So if I minus coin 1 is negative, we just get rid of this sum and we just do the next one. Yeah, so now I'll code it out. So first we'll take in the inputs. Right, and then now that we have taken the inputs, we want to make the actual DP array, right? So long DP of size x plus 1, and then we will fill it up with 0, right? Because the initial value for every one of the the states will be 0, and then we want to have a base case. So the base case here is that DP of 0 there is 1, which means there is one way to get 0, the sum 0, right, using the coins. So now we want to traverse over each state. So 1, and when I say traverse, it basically just means loop over. It's just a fancy way of saying it. I learned it in AP CSP last year, and I found it pretty cool. So yeah, all right, and now we're gonna loop over each coin, and we want to say if if I minus array of coin j, so the state minus coin j is greater than or equal to 0, we want to say that plus equals dp of I minus rj, right? And then we can't forget to mod it. course, or do the modular. All right, and then finally, well, I have so many white spaces here. All right, and then finally we just want to print the answer, so which will be dp of x. All right, let's see if it works. Whoops, what did I do here? Oh, all right. Yep, it does work for our input they've given us, the sample input. Let's hope that it works. Yep, it does work. So when you're actually doing this problem, if you have fallen into like this little thing where some of the problems give you what time limit exceeded, don't worry about it. I'm pretty sure the solution was actually right. The last time I did this problem, I'm pretty sure I got the same thing. I had like a couple problems with time limit exceeded. But then when I looked over at the solution, it was basically the same thing, but they just had done it so they just didn't use a memset, right? They didn't use memset dp0 size of dp to fill in each value, and instead they used a for loop. So I think for loop is doing it by for loop is just faster. That's why that happened. The time complexity is supposed to be the same, but I guess some constant time factor just takes over and ruins the solution. But yeah, don't worry about it if that happened to you. It's happened to me. But yeah, that's how you do the problem. Bye.